These are the gate network theory question. There are some around 6 questions I am discussing here. This one is the first question which are asking 2023 gate and for 2 marks. Uh, Basically, these questions based on the transit analysis, and some of them are based on two-port network. So to solve the network theory question, we only consider two things. First is KCL and second is KVL. Not more than this, not more than that. Only these two equations will solve almost every question. And you have to know about the transient analysis concepts like the instant voltage change not occur in the capacitor means Vc0 minus of the capacitor is equals to Vc0 plus of the capacitors. And for the inductor part, the instant there is no instant change in current. There is no instant change in current. So I L0 minus is equals to IL0 plus. Here, these are the property for the voltage and current for the circuit. And now we have to solve the question. So in this question, in this the initial condition is this: when switch 1 is closed and switch 2 is open, and the final condition is switch 1 is open and switch 2 is closed, and we are seeing this for t is equal to 0 plus time. At that time we have to find the IC current of the capacitor. So in this first, the question says that the circuit in this condition for long time means circuit will achieve steady state. Yes, circuit achieves steady state when t is less than 0, and for steady state capacitor cap opens and inductor becomes short for steady state. Short. And how why this happens? Like in steady state, the frequency is 0, so the impedance of the capacitor becomes infinite, and when frequency is 0, the impedance of the inductor becomes 0, so it will behave as a short circuit and the capacitor will behave as a open circuit. So in this time frame, if we draw the circuit, this is the 1 ampere source, and this is open, and oh, this is open. There is something. There is a resistance here which is of 100 ohm. This value is mentioned here. No, there is not short circuit. There is a resistance here. Okay. So this resistance is 100 ohm, and the for steady state this inductor will become short, and this is 100 ohm, and this is 25 ohm. First, uh, let's find out what is the voltage in the capacitor on when it is in steady state. This combination of this resistor will become R is equals to 100 into 25 by 125, which is this is 5 R equivalent for this R equivalent is 20 ohm. Now this resistance is 20 ohm. So the voltage across this resistor, as this 1 ampere current flow through the combination of this resistor, so there is a voltage drop which is of the voltage drop across this equivalent resistance is 20 multiplied by 1, which is 20 volt. So this all 20 volt appears to this capacitor. So when the circuit in steady state, the capacitor have voltage of 20 volt. So we find out that Vc0 plus, which is 20 volt, and not 0 plus, sorry, 0 minus when the circuit is in steady state. Now when we go to the 0 plus state, then the voltage will not change as property of the capacitor, which is 0 plus. Now we have to find the current in this branch, as inductor is here, so we have to find out the current in the inductor. Also, this is the combination of two resistor, which is 125, and there is a current source. There is a current source. So by using current divider rule, we can find the current in this branch, which is current in this 100 ohm resistors, which 100 ohm resistor, which is the opposite resistor by 100 plus 25, which is 1 by 5 and 0.2 ampere. So the current in this branch, or we can say the current in the inductor at its steady state, 0.2 ampere, and which is equals to current in the inductor at 0 plus stage. Okay, as the property of the inductor. Now for the final part, when t is equals to 0 plus, the capacitor will look like this, as switch S1 is open, switch S1 is open and S2 is closed. So the circuit will behave like this, and this is S2 is closed, so there is no need of this resistance, and this is inductance, and there is a resistor of 25 ohm, and a current is flowing, which is of 0.2 ampere, and the capacitor voltage is 20 volt, and we have to find out this IC which are flowing into the capacitor. This IC we have to find, and there is another current flowing on this in this resistor, is which is of 20 by 25 of 0.8 ampere. Now if we apply the KCL here, KCL here, then we get the equation IC of 0 plus IC of 0 plus 0.2 plus 0.8, which is IC 0 plus of minus 1 ampere. So this is our final solution for this question, and we can say intuitively, the intuition behind is intuition. First you have to see the option. In option we can say there is uh, three current which is in positives and one current which is in negative condition. This is our final answer. And how can we take intuitively minus 1, as the final stage? In final stage there is no active component, means there is no voltage source or no voltage source or current source which can charge this capacitor, this inductor and capacitor. So eventually the voltage appears, and voltage at t is equal to 0 plus on the capacitor start decreasing. Whenever the current start decreasing of the capacitor, it will flow outward of the capacitor. So the final current, final IC we get, which of negative sign. Okay, the final current we get practically is negative. This IC, as IC, we have to find our IC in this direction. So we can take the negative current intuitively, which is minus 1 ampere. Now move to the second. Okay, so in this two-port network, there is two-port network. We have to find out the admittance parameter. Admittance parameter means y matrix. Y matrix is y11, y22, sorry, y12, y21, and y22. These are the admittance parameter. And what is the independent, what is the dependent parameters here? We can find out by this equation, as this is admittance, this is impedance. Admittance is the inversely proportional of impedance, and admittance formula is IV. So if this, we can say that I is equals to YV. So this is dependent parameter and this is independent parameter. So the I1, we can find out this, we can remember this equation as I y v1. So uh, I y y11 v1 plus y12 v2, and I2 is y21 v1 plus y22 v2. These are the these this matrix is here as y11, y12, y21, and y22. We have to find out these whole parameters. So remember what I said in the start. We have to use only KCL and KVL in the equation. Then we can find out these equations easily. So in this current I1 is flowing in. We have to focus on this node and this node. I will say this node as X and I will say this node X as a Y. Okay, or we can say no need to mention X or Y, V1 as this is V1 and V2, V2 as this is V2. Okay, so first we apply KCL at V1. So this is input current and this is also input current, and there is an outgoing current and outgoing current. So now write the equation, uh, I1 plus V1 by 1 ohm, and all these only units in ohms, 1 ohms. This is the input current, which this one and this one is input current, which is equal to the output current. Output current is, oh sorry, I made a blunder. This is not an input current. This one is the input current, which is 3V2, which is 3V2, oh, which is 3V2, which is equals to V1 by 1, as this current is V1 by 1, this one V1 by 1 ohm plus now now this current, as this is also the outgoing current, which is V1 minus V2, V1 minus V2 upon, and this is 1. Now rearrange this equation and find out I1 current. So I1 is equals to, this is 3V2, this is V1, V1 plus V1, which is will become to V1, and this is 3V2, and if we solve we will get minus 4V2. This is equation first, and apply KCL at V1, sorry V2. At V2, this is I2 is the input current. This one is outgoing current, and this one is also outgoing current. So I2 is equals to V2 by 1, V2 by 1 plus this is V2 minus V1 by 1. Now this is V2 by 1, this is V2 by 1. So I2 is 2V2 minus V1. Now rearrange in this configuration. So I1 is V1 minus 4V2, and I2 is minus V1 minus 2 minus 2V1. Now compare with these two equations, we will get the y parameters. So the y parameters is y admittance matrix is, this is y11, so 2. This is y12, which is minus 4, and this is y21, which is minus 1, and this is y22. Okay, this is plus. Okay, this is plus, which is plus 2. So this is our final solution. Now move to the third question. In third question, yes. In third question, we have to find out this dVc. This is capacitor voltage. This dVc by dt at t is equal to 0 plus. First, switch at p for a long period of time. Then at t is equal to 0, switch move from S to Q. This is also a simple transient analysis question. For a long time, we can assume the circuit in steady state, and steady state we know capacitor open and inductor will short. Okay, so if we draw the circuit in t less than 0 time period, this is a positive source. Uh, this is voltage source 20 kilo ohm. This resistance 5 kilo ohm. This resistance 5 kilo ohm. The capacitance is open, so we will solve by this, and this resistance and the inductance will short. So all these resistance are in series, and this series resistance I will say as RS, which is 5 5 5 10 or 20 kilo ohm. So first we see that this is dVc by dt and on the capacitor. Okay, so whenever we see this, we have to automatically click in the mind that we have to find out the current first in the capacitor, as ICT of the capacitor is equals to C dVc t by dt. Okay, if we find out the capacitance current at t is equal to 0 plus, then we will easily find out the VCT at t is equal to 0 plus. Okay. So this resistance is 20 kilo ohm, and this is 20 ohm voltage source. So we can say that this 20 and on this 20 kilo ohm, there is a plus minus 20 volt voltage source. So we can say current IC at 0 minus IC at 0 minus IC at 0 minus is uh, which is this is mm, 20 20 volt by 20 kilo ohm and 1 milliampere current, 1 milliampere current, which is IC 0 minus 1 IC 0 minus, this is 1, this is 0 minus okay, 1 milliampere current. Okay, let me check the question. Hmm. This is 1 milliampere current, and the property of inductor also says that the inductor current is also 1 milliampere, as this current is, this is the current flow in this RS. So if we find out the current in this branch, which is also the 1 milliampere. So now we have to find out the voltage, and voltage is a voltage on capacitor. Okay, as we find out the, no, this is not a capacitor. That's where I'm making a blunder. It is not a capacitor current. This is not capacitor. This is a resistor current. So wait a minute. This is not a capacitor current. This is a inductor current. We find the inductor current as this is a, this is 20 kilo ohm, and the 20 volt source, 20 volt voltage source apply here. So 1 milliampere current flow in this branch. Okay, if 1 milliampere current flow in this branch, so we know the inductor property as 0 minus IL 0 plus is 1 milliampere. Now we have to find out the voltage on the capacitor, and this is 10 kilo. This one resistor is 10 kilo. If we separate out this circuit, this is capacitor, this is resistor, and we know the current flowing in this 10 kilo ohm resistance is 1 milliampere. So the voltage drop on this resistance is 10 volt. This all voltage source appears on the circuit on the capacitor. So VC 0 minus, you know the VC 0 minus, VC 0 minus is 10 volt, and which is equal to VC 0 plus as the, this is the property of the capacitor. So now we have to find out the IC current, and how we find the IC. How can we find the IC at t is equal to 0 plus? Um, Now at t is equal to 0 plus, switch move from this position to this position. So the circuit will behave like this. This is this sorted part. This is 5 kilo, and this is capacitor which has a 10 volt 10 volt 10 volt on the capacitor. The capacitance is 1 millifarad, 1 millifarad capacitance. And now the now this resistance, and resistance with this 1 milliampere current source which is flowing in the inductor, and this is 10 kilo ohm, 10 volt 1 millifarad, and this is 5 kilo ohm. Oh, this is at t is equal to 0 plus time frame, and we have to find this IC. IC is 0 plus, and now we apply the KCL here. In the KCL here, this is 5 kilo ohm and this is 10 volts. So a current will flow in this direction. A current is flowing in this direction. So this is 1 milliampere plus IC 0 plus, and this is 5 kilo by 10. 5 kilo ohm by 10 kilo ohm, sorry 10 volt, 5 by 10, which will give, no, 10 10 volt by 5 kilo ohm is equal to 0. If we solve, we get minus 3 milli ampere current. This is IC 0 plus. Now if we find out this IC 0 plus, then we can find out the DC dVc by dt, as IC is equals to C dVct by dt. So dVc at 0 plus by dt is IC by C, and we know IC is minus 3 milliampere and C is 1 millifarad. So it will cancel out, and this will become minus 3 minus 3 volt per second. This is our final solution for this question. Now move to the next. In this, the same concept of first we know this node is 1, this node is second. Apply KCL here, KCL and KVL only. Sorry. There is no connecting point here, so no current will go here. In the I current here is 0, so all the voltage VTH appears at second node. So this second node is itself a VTH. Okay, so all this VTH appears here. Now we can easily apply KCL and KVL here. In this we have to find this VTH. At node 1, uh, this is input current, and I am denoting this as node 1, so V1 voltage is there, and this is which is VTH. This V1 and actually made actually this configuration is like this plus minus 2 volt, and if we represent this V1 as another voltage source of plus minus V1 plus minus V1, so we can add this voltage which is 2 plus V1. Okay, so at a node 1, this at node 1 a current which is 1 milliampere is flowing there, and another current is flowing this side. This is input current, and these two are outgoing current. So if we apply KCL, the 1 ampere current is equals to the current flowing in this branch, which is 2 plus V1 minus, and this node voltage is VTH upon this resistance 2 ohm. This one is this current, and now for this current this will become V1 by, and what is this, wait a minute, I forgot to mention this. Let me check. Okay, this is 1 ohm, this is 1 ohm, so V1 by 1. Now if we solve this, we will get a equation containing VTH and V minus. So solve this is 2, this 2 will go here, and this is 2 plus V1 minus VTH plus 2V1. This 2 is cancel out, and this 2 will cancel out, or this is 3V1 is equals to VTH. This is first equation, and the second one is this. Let me see. Hmm. This is equation first, and if we apply KCL at node 2, if we apply KCL at node 2, uh, there is no current flowing here, but a current will flow here and here, and this is an input current of 2 ampere. So this is input current, these two are the out. Okay, let's This is input current, this one is the outgoing current, and this one is the outgoing current. This one is the outgoing current which is flowing in this direction, as no current is flowing in this direction. So this one is one current, this one is one current, and this is one current. It is input current. This one is the outgoing current. If we apply KCL at node 2, this is 2 ampere is equals to, and this is VTH minus the combination of these two, 2 plus V1 by 2 plus uh, this is VTH by 2, VTH by 2. Now solve this. This will go here. This is VTH. VTH becomes 2 VTH minus 2 minus V1, and this 2 will go here. It will become 6. This is 2 VTH and minus V1. And we know the V1. 3v1 is 3v1 is equals to VTH. If we multiply this equation by 3, this is 6 is 18, 6 is 3 3 से मल्टीप्लाई कर रहे हैं तो 3 6 80, 3 2 just 6 VTH minus 3 V1, and V1 3v1 is equals to VTH, so 5 VTH 18, so VTH is 18 by 5, so VTH is 18 by 5, which is equals to, let me calculate what is 18 by 5 is. I am correct or not? Yes, so it is 3.6 volt. So VTH is 3.6 volt. It is simple. Now move to the next. This is kind of I can say this is a speed run solution.